Welcome back. So, we were talking about powers of square matrices. When A is an n by n, that is a square matrix, we can take its power. Say, for example, here is a square matrix that you have, right? I'm not going to compute it, but this matrix to the 0th power is the identity matrix by definition. Okay. Next, this matrix to the first power is itself. This matrix to the second power is matrix multiplied to itself twice. This matrix to the third power is matrix multiplied to itself 3 times, and so on. Okay, so that's how you define powers of square matrix. Remember, in the previous video, we saw how you multiply matrices. So you know to multiply this matrix to itself, power 2. Power 3, this matrix to itself 3 times, and so on. Next, transpose. Transpose is a matrix. Let's read it. Let A be the matrix Aij, M by N matrix. Transpose of A, denoted by AT, is the N by M. So M and N are interchanged, obtained by interchanging the rows and columns of A. In other words, let's construct a 4 by 3 matrix and find its transpose. Okay, so let's construct a matrix which should be 4 by 3. 4 by 3 means 4 rows and 3 columns. So 4 rows, 3 columns. So let me put in some numbers. Okay, so this matrix, let me see what transpose of this matrix is. Transpose, so this is 4 by 3. So the transpose will be 3 by 4. Okay, interchanging rows and columns, interchanging rows and columns. So what did I do with the 3 by 3? That's the first row of this matrix. So when I convert it into a column, I'll get 2, 2, 3. That's the second row of this matrix. I'll convert it into the second column. That's the third row of my first matrix. I'll convert it to my third column. This is the last row. I'll convert it to the last column. So transpose results in a different size matrix where rows are converted to columns. Okay. A square matrix is called symmetric if A is A transpose. Okay. Let's take a square matrix. Okay. Let me say make it size 4 by 4. Square matrix means same number of rows as in columns, right? So I want it to be symmetric. What does that mean? I'll give it some diagonal elements. Okay. Of diagonals, say I give it 1, 3, 4. Then I should give it 1, 3, 4 here. So symmetry along the diagonal. So this is 1. So I need, suppose I have 6 and 7 here, then across will be 6 and 7. That's 3. Suppose I have a negative 2 here, it should be negative 2 over here. Why is it called symmetric? Look at the diagonal. If I flip it across, I get the same matrix back. What's the point of this? Look at its transpose. Transpose will be another 4 by 4 matrix. If you recall, how do we define transpose? You take the original rows converted to column. So I'll take my original row. First row becomes first column. Second row becomes my second column. Third row becomes my third column. Fourth row becomes my fourth column. Look at that. Did I get the same matrix back? Yes. So a symmetric matrix is a square matrix whose transpose is itself, and it's symmetric about the diagonal. All right. 0, 1 matrices. Well, a matrix all of whose entries are either 0 or 1 is called a 0, 1 matrix. Okay. Let's continue on 0, 1 matrices in our next video.